Assalamu alaikum students. This is video number 2 for the revision of end of term 1 exams in mechanics. So as you can see in front of you, the chapter number 6, friction. Unit number 6.1 is rough horizontal surfaces. Question number 1 says that the following diagram show a solid block of granite of mass 700 kg is at rest on a rough surface. Given that the coefficient of friction between the block and the surface is 0.4, state whether the forces applied are enough to cause it to move. So one thing we need to understand, the limiting friction is what? The formula for the limiting friction is, I can call it as F max, and that is equals to mu r. And mu is called coefficient of friction, where R is the normal reaction. A normal reaction is basically connected with the weight of the body, or it is the contact force. Now, we have different contexts, different diagrams are given to us, and examiner is asking us, will the particle move or not? The first case is I have a 700 kgs mass, then obviously the weight will be 7,000 newtons, and my reaction will be also 7,000 newtons. Now, since it is in the position of rest, so 2,000 will be equals to F. So the friction, if it is not moving, so the F is equals to 2,000 Newton. Now, I need to check that what is the F max of this situation. F max is equals to mu r. In this particular context, the value of the coefficient of friction is given to me 0.4 and the reaction is 7,000. Now, when I multiply them, guys, it gives you 2,800 newtons. Now, 2,800 Newton is more. Your F max is more than the friction. So the body will stay in the position of rest. As long as my friction is less than the F max, the body will always stay in the position of rest. F can be increased maximum to F max. If the value of F gets bigger than the F max, at that time, the body will start moving in the direction of the force. Now, if you look into the second situation, 700 kgs, okay. Now, I am applying 3,500 Newton to the right, and also I am applying 1,000 Newton to the left. Now, in this case, I am willing to find the value of the F. So F plus 1,000 is equals to 3,500, and F gives me 2,500. But still, it is less than F max, which is already found 2,800. So it means it is in the position of rest and it will not move. If we go to the question number 3, we are applying F 1,000 Newton to the right, 2,500 to the left, and F. But now the value of R will be changed. The equation of R will be R plus 2,000 is equals to 7,000. So R plus 2,000 is equals to 7,000. So this gives you R is equals to 5,000 Newton. Now F max will be what? It is mu R. So when I say my Fx is equals to mu R, mu is given to me 0.4. and this is 5,000. Now, when I multiply them together, I am going to get 2,000 newtons. Okay. Now, equation of F is what? F plus 2500 is equals to 5,000. Okay. So now you can see F comes to you as 2,500. Now, F is bigger than F max. This is the situation when the body will start moving in the right hand direction. Fourth case, you can see equation is changed. Now, R plus 3250 is equals to 7,000. So R will be equals to 3750 newtons. Now F max, first try to get your F. F plus 2000 is equals to 6,000, and F comes to you 4,000. Let me try to get my F max in this case. Mu was 0.4 times 3750. When I try to calculate my F max, it comes to me 1500 newtons. Now, F max is smaller than the F force, which is 4,000. So it means the body will definitely move towards right. Question number 5. Before I start applying the Newton's second law, I need to resolve 2,000 Newton force horizontally and vertically. So this becomes 2,000 sine of 30, and this is 2,000 cosine of 30. Friction, yani this is F. So your F will be equals to 2,000 cosine of 30. But I have to get my R. R plus this, R plus 2,000 sine of 30, put it equals to 7,000. So my friends, after simplifications, your R will come equals to 6,000 newtons. Now, what is my F max, which is mu R? Mu is 0.4 times 6,000, and that gives you 2,400 newtons. Now, let me try to calculate my F. So the F comes to me equals to, let me use my calculator. After calculator usage, it gives us to give it to us 1732. Now F is smaller than the maximum F max, and the maximum friction or the limiting friction. This is the case when the particle will not move. Now come to the question number 6. 3215 force has to be resolved. So this is 3215 cosine of 20 and 3215 sine of 20, and also resolve the downward force 5500 cosine of 35, and this is 5500 sine of 35. Now let's talk about our R. R is this, R plus this, and is equals to 7,000 plus this one. So let me write the equation for R. R plus 3215 sine of 20 is equals to 7,000 plus 5500 sine of 35. By using equation solver, R comes to me equals to 9055 newtons. Now, F max is what? F max is mu R, which is 0.4 times 9055. F max equals to 3622 newtons approximately. And then what was your F? Your F was F plus 2000 equals to 3215 cosine of 20 degrees plus, I'm talking about these two, plus 5500 cosine of 35. After solving, I get value of f equals to, the value of f is, it comes to me 5526. Now, since my f is bigger than f max, it means the particle will start moving right. So this is a very good application of f max. If your friction value gets bigger, yani if I see that f is bigger than the f max, definitely the particle will start move. But if f is less than f max, then particle will stay in the position of rest. Now we go to the question number 2. A particle of mass uh, 0.2 kgs lies at rest on a rough horizontal plane. Our horizontal force of 1.2 Newton is applied to P, given that the P is in limiting equilibrium. So when P is in limiting equilibrium, when the particle is about to move, at that time, your applied force is equal to F max. Suppose this is the horizontal place where the particle is, the mass is kept 0.2 kgs. Okay. 2 Newton is the weight, reaction is upward, and you are applying a horizontal force of 1.2 newtons, and there is F max. Since the particle is in a limiting equilibrium, your F max should be equals to 1.2, the applied force, and which is equals to mu r. R will be equals to 2 newtons. So 1.2 divided by 2 is 0.6, and mu has no units. Now he said that given instead the coefficient of friction is 0.3, find the distance traveled by P in the third second. So it's pretty simple. A person needs to find F max first. F max is mu r. Mu is 0.3 and reaction is equals to 2. So this gives you 0.6 Newton. This is my F max. Okay. Now, what is the net force acting on a body? I'm going to write 1.2 Newton, which I applied on the right-hand side. And the left-hand side is 0.6 Newton applied. It is equals to how much? This is my F net force. Okay. And this F net force should be equals to MA. And the mass is equals to 0. Let me check what is the mass. 0.2 times A. This leaves acceleration as 3 meters per second square. Now, acceleration is found. After that, the guy is asking how much distance is covered in the third second. So we need to find how much the particle will cover the distance in the second or in the third second. So the best thing is, why not we can find a formula that the particle will find the distance in the second, second, and in the third second. The interval, that time which is between second and the third second will give you the total distance. So let's start. Our body is starting from rest. So u is equals to 0. I'm going to give you t is equals to 2 seconds and see how much distance is covered by the body. So S is needed to be found. Acceleration is 3 meters per second square. S is equals to ut plus half at squared. So u is 0. This is 2 plus half. Acceleration is 3. And this is 2 squared. And the final answer comes to me 6 meters. Now I'm also interested in the third second how much the particle travels. So u is equal to 0. and t is equals to 3, acceleration is 3 meters per second squared. So s is equals to ut plus half at squared. So 0 times 2 plus half times 3 squared. So I think I'm going to get 27 over 2. So 27 over 2 is 13.5 meters. Just subtract these two times, S1 minus S2. So S2 minus S1. So 13.5 minus 6 will give you the answer 7.5 meters. This is the distance which they will cover. Now we go to the question number 3, where he said a particle of mass 12 kg is going to be pulled across a rough horizontal plane by a light inextensible string. A string is at an angle of 30 degrees above the plane and its tension is T newtons. The coefficient of the friction is 0.5. Given that the particle is in the point to move, the moment I see this, it means that my applied force will be equal to F max. So let's resolve it. So this will be T cosine of 30, and this is T sine of 30. Reaction is R upward, 120 Newton is downward, and this is equals to F max. Now, why not? I can find R first. So R plus T sine 30, that is equals to 120 Newtons. Also, F max is equals to T cosine of 30. This is equals to mu R T cosine of 30. The value of coefficient of friction is 0.5 and the reaction is 120 and T cosine of 30 degrees. This helps me to get the value of T easily. So let's try to get your value of T. I'm using my calculator. So the calculator says 0.5 times 120 equal x times cosine of 30, close the bracket, and shift solve helps me to get the value 69.28. So that's the value of the friction I am gonna get. The value of the tension. Let me check it again. The value of the friction is, as you can see, it's T cosine of T sine. Is it T cosine? Yeah, T cosine of 30 degrees. Yes, these are the forces. Reaction I have already calculated. That came to me. Let me check my reaction force also. I think maybe I did a mistake. No, I cannot put here R 120, guys. So R is not known to me, because R is needed to be found. So this is R, and I can solve them simultaneously. I can substitute, because in this question I want to find the value of T. So why not find R, which is T cosine of 30 degrees divided by 0.5. I can substitute it here. So T cosine of 30 degrees over 0.5 plus T sine 30 degree is equals to 120. Now you can use equation solver. Okay, I'm bringing my calculator here. So let's see. X times cosine of 30 over 0.5, and I write plus x sine of 30, closing the bracket, and I need to write the equal sign, then 120, shift solve, and that gives me the answer 53.8. So tension is equals to 53.8 newtons, 3 significant figures. Then he says X, the particle instead of be on the position of movement. Rather, the particle is accelerating. So F net is equals to ma. So what is the right hand force he applies? He applies t cosine of 30, Newton's second law, t cosine of 30 minus F max is equals to ma. And ma's mass given to us 12 times a. I want to find t cosine of 30. F max is mu. Mu was fixed 0.5 and R was unchanged. R was 120 minus, you send it to the side, 120 minus t sine of 30. 120 minus t sine of 30 is equals to 12 times 0.5. Now write everything in the equation solver and see what is the answer we are getting. Let's write here x times cosine of 30 degrees, close the bracket, minus 0.5 times 120 minus alpha x sine of 30 degrees, close the bracket, is equals to 12 times 0.5. Shift solve, and that gives us the answer 59.1 is the answer. We got it. You can recheck your answer. 50. I wrote here the value of the acceleration when I wrote t cosine of 30 degrees minus 0.5, 120 minus t sine 30 is equals to 12 times 0.2, which is 0. I think, which is, is it 0.5? Let me check that. Acceleration is, oh yes, acceleration is not 0.5, that is 0.2. Go back to my calculator and change the value of our acceleration is. The value of the acceleration is not 0.5, it is 0.2. Now shift solve, it gives us 55.9 newtons, three significant figures. Now we go to the question number 4. In question number 4, a particle P of mass 0.8 kgs is placed on a rough horizontal table. The coefficient of friction is mu, and the magnitude of 5 Newton acts at an angle of alpha above the horizontal, and tan alpha is equal to 3/4 is applied to P. I think in the class I did mention to you, if tan of alpha is equals to 3/4, I can complete a right angle triangle. This is 3, this is 4. Obviously, by using Pythagorean, this is 5. This helps me to write sine of alpha is equals to 3/5 and cosine of alpha is equal to 4/5 rather than finding the value of alpha. Now, we have a horizontal table and there is a mass 0.8 kgs, weight is 8 newtons and it is equals to R. The force 5 newtons is making an angle alpha with the horizontal. So this is 5 cosine of alpha and this is 5 sine of alpha and this is F max. And he mentioned that the particle is on the point of slipping. If the particle is on the point of slipping, then definitely F max will be equals to 5 cosine of alpha and F max is mu R. Mu reaction is R plus 5 sine of alpha is equals to 8. So I'm going to write 8 minus 5 sine of alpha clear is equals to F max is equals to 5 cosine of alpha. Substitute all the values which are given to you. Mu times 8 minus 5 sine alpha is 3 over 5 and cosine alpha is 4 over 5. 5 cancelled. So mu times 5 is equals to 4. Mu is equals to 4 over 5 or 0.8. Next question is, he said a magnitude of force of P is increased to 10 newtons. Before that, it was moving, it was applying 5 Newton, now it is 10 Newton, with the direction of force remain the same. So direction of force remains the same, but now the particle will try to move as the force is increased. So we want to find the acceleration. So now Newton's second law we applied here. So 5 cosine of alpha, 5 cosine of alpha minus F max is equals to mass times acceleration, 5. Angle is staying the same, so cosine of alpha is 4 over 5. F max is mu times R, m times a, 5 cancel, 4 mu. The value of mu is 0.8. Reaction is 8 minus 5 sine alpha, 8 minus 5 sine of alpha, and the mass is 0.8 times acceleration. So 4 minus 0.8, 8 minus 5, and sine of alpha was 3 over 5. It's equal to 0.8 times a, 5 cancel. 4 minus 0.8 times 5 is equal to 0.8 a. Then you use equation solver, and that gives you a is equals to 8 meters per second squared. Now we go to the unit 6.2, which is rough inclined plane. We have to resolve all the forces. We have 650 Newton already acting along the plane. Can I resolve this force? So this is 175 cosine of 20. And there is upward force 175 sine of 20. Let me resolve this force, 100 newtons. So this is 100 cosine of 45 and 100 sine of 45. This force is the weight component 1000 cosine of 30 degrees. Let me resolve the weight component 1000 sine of 30 degrees. Now, is the system moving? Let me check. A diagram on the right shows a crate, 100 kgs being put on a hill. Okay, one man uses a force, this. Ropes, okay, inclined at 20 degree. If 100, okay, the crate and is inclined. What is the coefficient of friction? So looks like the particle is not moving. So the particle is stable. I need to get my reaction R first. So reaction should be equal to this plus this. So let me write here R plus 100 sine of 45 plus 175 sine of 20. That should be equals to 1000 sine of 30. So what is the value of R? Finally, we get it. The value of R comes to us, that is equals to 735.4, four significant figures, because we will use this value in later stage. This is the reaction R. We found it. But now my next job is to calculate the forces acting up the plane and down the plane. We need to add them up. Newton's second law. So 175 cosine of 20 degrees. This is upward force. Now, how many forces are downward forces? We have here, oh yes, guys, be careful. It is moving with an acceleration 0.8. 1 meter per second square. It's not in limiting equilibrium. So 175 cosine 120 and minus 100 cosine of 45 minus F max and also minus the weight component 100 or 1000 sine of 30 degrees. So these are the three forces downward down the plane, and it is equal to mass 100 times acceleration, which is 0.1. I need to write all the values here. 175 cosine of 20 degrees minus 100 cosine of 45. F max is equals to mu r. Mu I need to find. Reaction I already found, 735.4 minus 100 sine of 30 is equal to 100 times 0.1. Now I use the equation solver. That will give me the value of mu equals to 0.318. So listen to me carefully. This minus this expression and then minus this is equals to 100 times 0.1. Finally, you will end up with the value of mu is equal to 0.318. Now we go to the question number 2, where the mass is 12 kg, is on a rough inclined plane at an angle of 25 degree to the horizontal. The force of magnitude P Newton acts on the particle. This force is horizontal and the particle is on the point of moving on the greater slope. The coefficient of friction between the slope is 0.6 and find the value of P. So let me make an inclined plane. This is 12 kgs, resolve it. 120 sine of, what is the angle given to me? 25 degrees. 25, and this is 120 cosine of 25, which is equals to r. Okay, x on the plane, and this force is horizontal, and this force is horizontal. So you are applying a force here. This is the P force. Obviously, this is 25. So now let me resolve it. So this should be P cosine of 25, and this should be P sine of 25. Now reaction will be equals to R equals to this plus this. I'm going to write R is equals to 120 cosine of 25 plus P sine of 25. This is one equation. We got it. And as per the question, the particle is on the point of moving up. So F max plus 120 sine of 25 should be equals to the P cosine of 5 degrees, P cosine of 25 degrees. F max is equals to mu r, which is 0.8. 0.8 times r is 120 cosine of 25 degrees plus P sine of 25 degrees plus, right, this one, 120 sine of 25 degree is equal to P cosine of 25 degrees. My dear friends, I would love that if you copy this one on your calculator and use equation solver. That will give you the value of P equals to, approximately 242 newtons. Now we go to the question number 3. Question number 3 is basically, again, a block of mass 12 kg is placed on a rough plane, making an angle alpha. A force of x Newton is applied to the block directly up the plane. See diagram, the coefficient of friction. The value is given to you 0.15 and x is 20. Find the time it takes for the block to move 2 meters down the plane from rest. So this is 12 kgs. So this is u is equals to 0. And the angle is inverse tan of 0.5. Weight component 120. Sine of inverse tan of 0.5. You can calculate its value. It's not a big deal. So 120 cosine of inverse tan of 0.5. A force of x Newton is applied to the block directly up the plane. So there is an x force, which is 20 Newtons up the plane. Now I want to find the acceleration or deceleration. Obviously, it would be an acceleration. So if it is going down the plane, so I'm going to write 120, the F max will be upward. So 120, again, guys, I'm telling you this is going down. So 120 sine of inverse tan of 0.5, clear? And minus 20, the x value, minus F max, which is mu r, mu is 0.15, and your reaction should be equals to 120 cosine of inverse tan of 0.5 should be equals to MA, which is 12 times A. When I write it in my equation solver, and that will give me the value of acceleration equals to 5.83 meters per second square. Now, u is equals to 0 meters per second. Distance covered down the plane, it is 2 meters. If you know the three things, you can use equation of motion. S is equals to ut plus half at squared. S is 2. U is 0 times t plus half times 5.83 times t squared, which I actually want to find. So t will come to you equals to 0.83 seconds approximately to the two significant figures. So that's all about the friction, guys. Inshallah, it will be easier if you will do the practice. If any furthermore question comes regarding friction, you can discuss with me. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.